Fusion Mobile, quality e-learning experience on the go.
Welcome to Fusion Mobile e-learning clinic. My name is Sonyola and I'm guiding you through the chemistry course. In this particular topic, we'll be looking at phosphorus and its compound. I will start with phosphorus, then we'll go to phosphorine and phosphine. Then we'll talk about phosphorus 3 chloride, phosphorus 5 chloride, phosphorus 3 oxide, phosphorus 5 oxide. Then we'll look at Trioxophosphate 3 and Trioxophosphate 5 acids. And then we'll talk about the Tetraoxophosphate 5 acid. Then we'll talk about the Tetraoxophosphate 5 salts. Alright, let's begin with phosphorus. Phosphorus is a compound. It belongs to the group 5 elements, and it exists naturally in two different allotrophs known as the red phosphorus and the white phosphorus. About now, there will be a diagram on your screen, a table on your screen, to show you the differences between the white phosphorus and the red phosphorus. The red phosphorus does not glow, the white phosphorus glows. The white phosphorus is toxic, the red phosphorus is not toxic. Both of them are insoluble in water, but the red phosphorus and the white phosphorus is very soluble in carbon 4 sulfide. Of course, some of their chemical properties, of course, is that in air, rapid oxidation happens at ordinary temperature in white phosphorus, but it only happens in red phosphorus under heating. White phosphorus also blends with chlorine to form any of them, but only works with chlorine when heated. That is for red phosphorus. Of course, when you react phosphorus with hot H2, that's sodium hydroxide, it is only in the white phosphorus that the phosphine would be formed. Alright, let's talk about the chemical properties of phosphorus generally. Phosphorus generally reacts with oxygen in the presence of excess air to form the P4O10. That is known as the phosphorus 5 oxide. And when this particular compound reacts with water, it would form what we know as the Tetraoxophosphate 5 acid. Also, when there is limited air, in the presence of limited air, phosphorus reacts with oxygen to form what is known as P4O6, which is the phosphorus 3 oxide. And of course, this also produces an acid, which is the Trioxophosphate 3 acid. Yes, when phosphorus reacts with sodium hydroxide, that is alkaline, as we discussed earlier, of course the white only does this reaction. It produces phosphine as the product. So let's go ahead to talk about phosphine. Is a chemical that is represented by the expression pH 3, just like ammonia. It looks like ammonia, but instead of you having nitrogen, it has phosphorus. It is a colorless liquid with a rotten fish smell. It is poisonous and slightly soluble in water. Unlike ammonia, it's only slightly soluble in water. It decomposes to form the phosphorus and hydrogen, which are the components that it's made up. It reacts with oxygen, excess oxygen, and the end result is the production of the Tetraoxophosphate 5 acid. It is a very strong reducing agent, and phosphine itself is basic in nature. It is basic in nature, and it reacts with certain acids to form complex salts, because it is a weak base, and weak bases tend to form complex salts most of the time. So having spoken about phosphorus and phosphine, in a few seconds some questions will be shown on your screen. Please attempt them. We want to understand, want to see what you've learned so far, and we'll see in a jiffy. Alright, welcome back. So let's discuss the sulfur 3 chloride. Sulfur 3 chloride is produced by bombarding phosphorus 3 chloride. Phosphorus 3 chloride is produced by bombarding phosphorus with chlorine. Of course, when you have about 6 molecules of chlorine, it will produce phosphorus 3 chloride. phosphorus. And this particular atom this particular compound does not really partake so much in many reactions. One of these few reactions is the production of what we know to be the trioxophosphate 3 acid. Of course, that is reacting the phosphorus 3 chloride with water, and to produce the acid, and it would also liberate the hydrogen chloride gas. Another obvious reaction is the reactions with alkyls and alkynes. Basically, in organic chemistry, we use it for testing compounds in organic chemistry. That's the phosphorus 3 chloride. Okay, let's discuss the phosphorus 5 chloride. Phosphorus 5 chlorides, they can be produced working from phosphorus 3 chloride. Well, just that in their own case, it sublimes. So when you heat it, it will go the forward reaction, that is producing phosphorus 3 chloride and chlorine. Well, when you cool it, it cools and it forms phosphorus 5 chloride. This phosphorus 5 chloride, when it is reacted with water, it forms the Tetraoxophosphate 5 acid, and it liberates the hydrogen chloride gas. It forms Tetraoxophosphate 5 acid and liberates the hydrogen chloride gas. Of course, the phosphorus 5 chloride is also used in organic chemistry for testing of different chemicals, especially the carboxylic group. Alright, let's quickly look at the phosphorus 3 oxide. The phosphorus 3 oxide is formed by reacting phosphorus with oxygen, limited air, in the presence of limited air, to form phosphorus 3 oxide, and it reacts with cold water to form phosphorus, to form the trioxophosphorus 3 acid. Also, if you react it with hot water, it will form the tetraoxophosphorus 5 acid and to give the phosphine gas. Also, if you look at the phosphorus 5 oxide, phosphorus 5 oxide will be formed from phosphorus 3 oxide in the presence of excess air. In the presence of excess air, phosphorus 5 oxide will form from phosphorus 3 oxide. If you react phosphorus 5 oxide with water, cold water, it would produce this particular acidic component. It's an acid salt. That's what produces. That's a trioxophosphate 5. It produces the trioxophosphate 5 acidic salt. And if you go ahead to react it with hot water, it will produce tetraoxophosphate. It produces tetraoxophosphate 5 acid. So those are the reactions that have to do with phosphorus oxides. These phosphorus oxides are also used in testing of certain chemical components. They are laboratory reagents. That's what we use them for. Alright, let's quickly look at trioxophosphate 3 acid and tetraoxophosphate 5 acid. Alright, let's quickly consider trioxophosphate 3 acid. Trioxophosphate 3 acid is produced, of course, either two ways we can use in producing it. You can react phosphate 3 oxide. You can react it with water, or you react phosphate chloride, that's phosphate 3 chloride, with water. Both of them will produce the acid. Okay, the acid has a unique structure. That's what we have on the board here. It has oxyl, hydroxyls, and the hydrogen. This is the hydrogen that forms the structure, the function of the acid, and the oxygen is also there. You know, phosphorus has 5 valence electrons. 1, 2, 3, 4, 5. So 2 of it connects to one oxygen, and the other ones connect individually, 2 to the hydroxyls and 1 to the hydrogen. So these hydroxyls are not hydroxyls like the way we see them in bases. Rather, they are just a part of the phosphorus compound. So the phosphorus compound actually can depreciate, it can decompose into phosphorus, and that's tetraoxophosphate 5 acid, and phosphine. That's the major thing that it does. It decomposes. It is a very, very weak acid. It's a very, very weak acid. Okay, so let's quickly look at the tetraoxophosphate 5 acid. Tetraoxophosphate 5 acid is actually a deliquent substance. It is liquid form and it is viscous. It is produced in the laboratory by reacting the salts of it with Tetraoxophosphate 6 acid. That's in this particular condition we have calcium 2 potassium tetraoxophosphate 5 molecule being reacted with tetraoxophosphate 6 acid, and we have a reaction resulting in the production of calcium tetraoxophosphate 6 salts and tetraoxophosphate 5 acid is being produced. Now the structure is just as what we can see here. This isn't part of it. It doesn't decompose that way. The decomposition, it decomposes to form this particular structure, that's H4PO7 and water, and it can further decompose to form HPO3 and 2 molecules of water. These decompositions are reversible reaction, and they can occur at temperatures of about 200 degrees Celsius. 200 degrees Celsius. Okay, apart from that, what are the other properties of the acid? The acid, it is a weak acid. It's a very, very weak acid, and it is displaced by other substances, by other acids in its form. It is displayed. It's always displayed by other acids, either in the salts or in even the oxides can displace it from its own acid. All right. Let's take a quick look at the tetraoxophosphate 5s, that's the salts, and we'll wrap it up. Tetraoxophosphate 5s, the salts of tetraoxophosphate 5s, they are the salts of the acids that we've been talking about, that's tetraoxophosphate 5 acid. These salts, because the acid is has a basicity of 3, that is tribasic. It has a basicity of 3, so it has 3 hydrogen atoms which can be liberated from the acid. 3 hydrogen atoms which can be liberated. So this makes it to form different kinds of salts, even though it is reacting with alkaline metals. The different kinds of salts along whichever alkaline metal it reacts with will be based on all of this configuration. It can be monosodium, that's monometal phosphate, that is monosodium tetraoxophosphate 5. It can be disodium tetraoxophosphate 5, and it can be trisodium tetraoxophosphate 5. Now this particular first one will still react, it still take part in chemical reaction until it forms its next one, till it forms the final one. So in their existence, this is how they operate. They do not until it attains this, it does not attain any form of stability. It does not attain any form of stability. There is a chance of it decomposing at any point in time. Okay, we've talked about phosphorus and its compound. We looked at phosphorus. We spoke about phosphorin, and phosphorus is P8 and P4. It exists in the 4th level. We talked about phosphorin, which is PH3. We talked about phosphorus trichloride, which is PCl3. We talked about phosphorus 5 chloride, that's PCl5. We talked about phosphorus 3 oxide, that's P4O6. We talked about phosphorus 5 oxide, that's P4O10. We talked about trioxophosphate 5, which is H3PO3, and tetraoxophosphate 5. Trioxophosphate 3 and tetraoxophosphate 5. Tetraoxophosphate 5 is H3PO4, and tetraoxophosphates, they are generally PO4 3-. So depends on which of them, whether they have plus H with them or not, or without the plus H. Generally, phosphorus have a lot of application in making of fertilizers. Alright, we've learned so much about phosphorus and its compound. In a few seconds, some questions will be displayed on your screen to test your understanding of this lesson. Please do answer them, and if there is any part of it that seems confusing, you can go over the video one more time.